Let's look at one more example in conditional probability. Alright, so now this is the situation. There are two identical coins in the box, right? However, one of them is a fair coin, the other is a biased coin. Alright. Now there's no other way to distinguish, right? The physical size, the shape, the color, the weight, the dimension, everything, they are the same. Alright. The only difference is that one of them is a fair coin. By fair, I mean you will have 50% chance of head, 50% chance of tail. But the other is biased towards heads. There is a 90% chance of tossing a head, but only 10% chance of tossing a tail, right? So how do you, if you pick up a coin from random, right? How do you differentiate it is a fair coin or the biased coin? How do you know? Well, you can't tell elsewhere. It's the same color, the same shape, the same size, the same weight, everything is the same. Alright. So one way perhaps you can do is to toss the coin. If you toss the coins, it shows many heads, right? For example, in this case, you toss the coin 4 times. 4 of them, they are all heads. What can you tell, right? Never mind the mathematics. Think about that in real life, if that is the case, right? One coin is fair, the other is biased. You pick it up at random. You don't know whether it is fair or biased, so you toss the coin. I toss the coin 4 times. 4 of them, they are head. So which do you think is more likely? Is it more likely the fair coin, or is it more likely the biased coin? I think you will agree that if you had tossed many times they are all heads, then probably it is the biased coin, right? It's more likely to be the biased coin. That is how we can say in our common sense. Because the biased coin will give you more heads. Now you have more heads, so it's more likely that it is a biased coin, right? Now here is the mathematics comes. What if I want to take it one step further? I know that it is more likely the biased coin, right? But how likely? Can they put it in quantitative sense? It is 80% likely to be the biased coin, 90%, 95%, 98%. Do you have a number? Do you have a quantitative description of the likelihood? Right? What do you think? Is it 90%, 80 or 95? Now have a guess before we move on to the calculation. Now first we try to use the probability symbol to indicate this. Alright, we are calculating what is the probability that it is a biased coin given 4 tosses, they are all heads. Alright, now this is the symbol. Alright, what is the probability that it is a biased coin and then you have 4 heads? Alright, now before I calculate this one, now this is the answer. This is the likelihood of being a biased coin if 4 of them they are all heads. Now let's look at the reverse one. What is the probability of 4 heads if it is the biased coin? Alright. Now the blue one actually is easy because we already know that it is the biased coin, right? This is the given condition. It already happened, alright? Given a biased coin in hand, you toss it 4 times. For all 4 times they are heads, the probability will be 0.9 to the 4th power. Do you get this? Because I know that it is the biased coin. The biased coin will give me 90% chance of a head every time. So I toss 4 times, and that probability will be 65.6%. Alright? But that is not relevant to the question here, as we can see in our previous example, right? These two numbers, they are not always the same. In fact, most of the time, they are not the same, alright? So, it's only a reference, right? If it is a biased coin, the chance to get 4 heads will be 65.6%. But what if the situation is reversed? We don't know whether the coin is biased or not. We only know that it is 4 heads coming up at 4 tosses, alright? So what is the probability that it is biased? Right, now it is an advanced idea in probability. It's not just whether an event happened or not. It is something happened and how does it affect the probability of another event, right? Without this 4 heads, right, you just pick a coin from random. What is the probability? It is biased. It's 1/2, right? Straightforward. Right? Without the tossing, you just pick a coin. And what is the probability that it is biased? That will be simply 1 over 2, 50%. Alright? Without tossing, before you do any tossing, you just pick the coin from random from the box. Alright? The probability that it is the fair coin is 50%. Biased coin is 52%. Alright? But the same coin, you toss it 4 times. 4 times they are all head. Now, it is the same coin, but the probability that it is a biased coin becomes higher than 50%. Now, remember what we need to know. What we need to know is the probability of it being a biased coin if 4 tosses, they are all head. Okay? So according to the Bayes theorem, this will be the probability of biased. You pick up a coin, it is biased, and then you toss it 4 times. All 4 times will give you a head, alright, and it gives you 4 heads, H, alright. Divide by the probability that you get 4 heads nonetheless. Never mind it is fair coin or biased coin, am I right? This is an exact copy of the Bayes theorem. I just replace the events A and B with biased and 4 heads, alright. Biased. 4 heads and 4 heads, alright, H, and quadruple H, alright, like this. So we need to calculate the numerator and the denominator. The numerator is easier because, if you think about the tree diagram, right, it's helpful to think about the tree diagram. You pick up a coin, it can be a fair coin, it can be the biased coin, right? Each one will give you 50%, right? For the fair coin to give you 4H, for the fair coin to give you 4 heads, the probability will be 1/4, 1/2 to the 4th power. Am I right? Otherwise, the probability will be just 1 minus that number. Other combinations, right, other than 4 heads, will be 1 minus that orange number. Because we know the sum of the 2 probabilities coming out from the same node, they should add up to 1. These 2 branches, their probability should add up to 1. Okay? So much about the fair coin. And then let's move on to the biased coin. It's similar to the biased coin, right? Only that we have 4H for the biased coin will be 90% to the 4th power. Alright? And then once again for the other branch, it will be other results other than 4H will be 1 minus 0.9 to the 4th power. Alright. So to get 4H, it is either this branch, you pick a fair coin and you got 4H. Alright. The probability will be 1 over 2 for the fair coin and 1 over 2 to the 4th power for the 4 heads. Alright. And then the second way to get 4H is that you pick up the biased coin, alright, and then you toss 4 heads nonetheless. Alright, you pick up the biased coin, the chance will be 1 over 2. To have 4 heads, the chance is 0.9 to the 4th power, right? So the total probability of having 4 heads will be the sum of these numbers. Alright, having 4 heads will be the sum of these numbers, and the decimal goes to something like this. Alright, it's about 35% chance you got 4 heads. Alright, so let's go back to our original question now. Alright, to have a biased and 4 heads, the probability will be this one. You pick up a biased coin, 1 over 2, and then you toss 4 heads, will be 0.9 to the 4th power. Alright, divide by the denominator. The denominator will be this number. Alright, will be this 0.3594 is the probability of 4H. Alright, let me copy this value. Okay, and the answer now is 91.3%. Now this is a quantitative description of the likelihood. If you toss the coin 4 times and they are all heads, right? The chance of the same coin on your hand, but the more heads you toss, the more likely it becomes the biased coin. Alright, so it's interesting. the coin does not change, all right? But the event will change the probability of whether the coin is biased or fair. If you just pick it up from the box fresh, it is a 50% chance it is biased. And then you start to toss it. The more heads you toss, the probability of the same coin on your hand will increase its likelihood in terms of being biased, right? So in this case, to put it in exact number, if you have 4 tosses, they are all heads, then the probability is being a biased coin will be 91.3, alright? Now you can try to verify this yourself. If you toss like 10 times, they are all heads, alright? Then the probability of being biased will be even higher than 91.3%. On the other hand, you can also calculate this. If you toss it 4 times and that 4 times they are all tails, then it is more likely that the coin is a fair coin, and so on. Alright, you can try this calculation. If you want to know more about the answer, you can discuss in the comments in that module. Alright, so this is one more example on the advanced idea of conditional probability.